Hi everybody, and welcome to an introduction on the solutions unit that we're going to be doing next. So up to this point, we studied a little bit about the solid phase, and I have here a sample of ammonium nitrate, NH4NO3. And of course, we've talked about the liquid phase. I have here simply a beaker of water. What we're going to do in this next unit is we're going to start putting solids into liquids and making solutions. Solutions are homogeneous mixtures. If you looked at a solution of where the solvent is water, you wouldn't know that it's actually made up of two different or three different things. You would think it's just water. So we're going to study solutions, and most of the time our solvent is going to be water and our solute will be some kind of a solid, but we'll also look at liquid-liquid solutions, and we're also going to look at gas and liquid solutions as well. But to introduce some of the basic ideas we're going to get into, I thought I'd do a quick little demonstration. And so I have here a beaker of water, and I've got a thermometer inside the beaker of water. And because the camera is kind of backwards here, it's going to look a little weird to you, but the temperature here is 22.6 degrees Celsius. So what I'm going to do is I'm going to take the aforementioned ammonium nitrate, and I'm going to go ahead and put it into my beaker of water here. Hopefully I can do this without spilling too much. And there we go. Whoops, spilled a little bit there, that's okay. It's just a little bit of salt, no big deal. Alright, now I'm going to swirl this around. Now ammonium nitrate is pretty soluble in water, and if I gave this enough time, you'd see that all the salt will dissolve. You can see that most of it already is gone. But now what I'm interested in figuring out is what's the temperature of this solution, because as I touch it, whoo, feels kind of cold. Let me put the thermometer in. Let it swirl around a little bit. So it was about 22, 23 degrees, and now the thermometer here is reading below 15 degrees, below 14 degrees. So the temperature here is starting to drop very noticeably, okay? So what I've done here is I've made a solution that's turned the water pretty darn cold relative to where it started. About 22, 23, down to about 12 degrees now. So that's one of the things we're going to talk about, namely the thermodynamics of solution formation. Sometimes when you make a solution, the temperature really doesn't change. Sometimes when you make a solution, it gets pretty cold. And we'll also see examples of when you dissolve a salt or a solid into water, you get a pretty hot solution. So we'll talk about the thermodynamics of solution formation. Now this solution has a certain concentration. If I paid attention to how many grams of ammonium nitrate I was adding, I could have gone ahead and figured out the molarity of the solution, or the molality of the solution, or the mass percent, or some other types of measures of concentration. And that's what we're going to start in the next video, is different ways to measure the concentration of solutions. We'll also talk about, instead of putting a solid into a liquid, we'll also talk about dissolving liquids into other liquids and dissolving gases into liquids. If you think about your soda that you might enjoy drinking, right? Do you remember the gas that's dissolved in that soda? It's carbon dioxide, right? And fish are happy that gases can dissolve in water because the oxygen dissolved in water allows fish to breathe. So we'll talk about gases dissolved in water and making solutions that way. Now, we talked about vapor pressure in the last unit, right? Vapor pressure is how much of the liquid evaporates above the liquid sample and generates a vapor pressure. This solution also has a vapor pressure. Some of the water is evaporating and creating a vapor pressure on top of the liquid. But for reasons we'll explore later on, it turns out that the vapor pressure of this solution is actually less than the vapor pressure I would have had if I just had pure water. We'll talk about how that comes about. So we'll talk about the vapor pressures of solutions. And when you make solutions, what you do is you change the behavior of the liquid that's in that solution. And this is, there are a number of different types of behaviors we can monitor. Boiling points and freezing points and other aspects of a solution. And all of these different behaviors are known as colligative behaviors or colligative properties. So we'll talk about the different types of properties that change when you make a solution relative to having just the pure liquid or the pure solvent. And then we'll wrap up with a quick discussion of a different type of mixture called colloids. Things like milk and butter, cheese, whipped cream. These materials are also mixtures, and they're also somewhat like solutions, but they don't look like liquid solutions like this, obviously. Those are called colloids. We'll talk about how colloids behave in comparison to typical solutions. All right, so that's about the 6 different ideas that we're going to get through during the course of solutions. And we're going to start in the next video with talking about different ways to measure concentrations. See you then.